Welcome to the grand finale, Junior Associates. We have reached Module 10-7, the final narrative. Think about a puzzle for a moment. Have you ever spent weeks putting together 5,000 interlocking pieces, only to realize you don't have the box lid? You have all the parts, but no idea what the final picture is supposed to be. In high-resolution mass spectrometry, this is exactly where most researchers get stuck. They have generated a list, but they are missing the signal. Today, we move from noise to high-impact biological signals. This is the consultant's guide to finding the why behind your data. Today, we find the box lid, and we finish the picture. To succeed, we must understand the shift from data points to discoveries. Most researchers treat a spreadsheet of 500 metabolites as a success, but lists are just noise. Signals are the truth. A list is just raw material for a story that boardrooms and committees actually care about. We are moving from being data collectors to becoming biological architects. In this final phase, we don't just find bits of straw in a haystack. We describe exactly how that haystack was grown. This systemic insight is what transforms your technical work into a professional discovery. Our framework for this transformation stands on 4 pillars of storytelling. First is the dictionary, which is the KEGG database. This is where we learn the vocabulary of metabolites as words in a biological sentence. Second is the engine, using MetaboAnalyst. Think of this as the Google Maps for filtering through 10,000 biological features. Third is the plot, where we apply ORA versus QEA logic to choose between a simple roll call or measuring the actual active workload of the system. Finally, we have the strategy. This is about selective focus, ranking your findings and picking the top 3 high-impact narratives. Let's look at Pillar 1, the dictionary of life. By themselves, molecules like glucose or citrate are just words. They are interesting, but they lack a story. However, in the context of a KEGG pathway, they become sentences. Our goal is to identify functional neighborhoods. If you see 10 metabolites all changing within the pentose phosphate pathway, you aren't just looking at a list. You are reading a story of cellular growth or a specific oxidative stress response. Identifying the neighborhood allows you to speak with authority about what is actually happening inside the cell. Next is Pillar 2, the narrative engine. You cannot filter 10,000 features by hand, so we use MSEA, or Metabolite Set Enrichment Analysis. This engine allows us to see the forest through the trees by using 2 critical metrics. First, the path impact score filters out the tourists, those molecules that are present but have very low influence on the outcome. Second, the enrichment p-value highlights the residents that have true statistical significance. Together, these metrics identify the actual drivers of biological change, ensuring your story is backed by mathematical rigor. Pillar 3 is about finding the plot by choosing your logic. First, we have ORA, or overrepresentation analysis. This is a roll call. It asks, is the number of molecules from a specific pathway higher than we would expect by random chance? It tells you who showed up to the party. On the other hand, QEA, or quantitative enrichment analysis, measures the workload. It asks, who is active? By using actual peak intensities, it measures the magnitude of change. This is essential for getting published in high-tier journals like Nature, where reviewers want to see the intensity of the biological response, not just a name on a list. Let's look at a case study, the glycolysis shift. Imagine your data shows a massive increase in lactate, up 450%, combined with a 70% decrease in glucose and an 85% depletion of citrate. To a technician, those are just 3 numbers. But to an architect, this is a smoking gun for anaerobic metabolism. Whether it is the Warburg effect in cancer or a case of mitochondrial poisoning, you are now describing traffic flow. You are no longer just reporting data points. You are explaining a biological mechanism of survival or failure. Now we move to Pillar 5, the selective focus strategy. Even though the slide says Pillar 5, it is the 4th and final stage of our logic. First, rank findings. Use path impact scores to prioritize results, rather than trying to talk about all 50 pathways at once. Second, pick the top 3. Focus only on the 3 narratives with the strongest statistical support and logical connection. Third, cross-validate. Use tools like VANTED or Impala to match your metabolite changes with gene or protein data. Finally, describe the mechanism. Is the traffic blocked or accelerated? Providing a mechanism is what builds your scientific credibility. Let's practice finding the plot. Imagine this scenario. You see 15 metabolites in the urea cycle that are all significantly increased, with VIP scores greater than 1.0 via quantitative enrichment analysis. You have two options. Option A, the cell is simply producing more protein for structural growth. Option B, which is our recommended interpretation, the cell is struggling with a failure in ammonia detoxification. Why? Because you are looking at the workload. Seeing the entire cycle backed up suggests a bottleneck in a critical waste management pathway. This is how you link pathway identity to biological stress. We have reached the end of our journey. Here is the final takeaway. Data is the alphabet. Pathways are the novel. Don't just list the letters. Tell the story. You now possess the full toolkit. From the physics of charge catalysts we discussed in the beginning to the strategy of narrative architecture we mastered today. You are now application specialists. You have the power to read the pulse of any sample and tell the world what it means. Go forth, honor your data, and use your stories to change the world of science. Thank you for your commitment to excellence.